This lesson, we're going to learn how to do cross product, which is also known as a vector product of two vectors. The cross product between vectors A and B is to create another vector that is perpendicular to both vector A and vector B. Let's look at this formula here for the cross product. Because magnitude of the A is a scalar, magnitude of vector B is also a scalar. Sine theta is also a scalar. That means the multiplication of scalar cannot become a vector. Therefore, it equals to the magnitude of the cross product. There are two ways to find the cross product, which will be illustrated in the next example. And keep that in mind, cross product is defined only in three-dimensional space. Example 1, we want to find a vector W that is perpendicular to both vector A and vector B, which means we are finding a vector W that is resulted from the cross product of vector A and vector B. Since we're doing A cross B, so we put vector A on the top and vector B on the bottom. Then we are ready to find our X coordinate and Y coordinate and Z coordinate of the vector W. Whenever we want to find the X coordinate, I want you to block the first column, which is the X column. And we will do 5 times by 2, which is 10, minus 1 times by negative 1, which is negative 1, which will give you the X coordinate, which is 11. Now let's do again for the Y coordinate. So once again, we block out the Y column, which is second column. Then we do 1 times by 2, which is 2, minus negative 1 times by negative 3, which is 3, which will give us a negative 1. However, in linear algebra, the second column always needs to times by another negative 1. So we say negative of 2 minus 3, which means negative of negative 1, which will become a positive 1. So that's a positive 1 here. Let's do it one more time for the Z coordinate now. So as for the Z, we cover the last column, which is the Z column. Then we do it again. 1 times by 1, which is 1, minus 5 times by negative 3, which is negative 15, which is 16. So our cross product is 11, 1, and 16. Usually, we do not write this 3 times. We use a pencil to cover the column to do the calculations as we go from the X coordinate to the Z coordinate. Method 2. We're going to write vector A on top twice. And we're going to write vector B on the bottom twice. And we're going to cover the first column and the last column. Then we do 5 times by 2, which is 10, minus 1 times by negative 1, which is 11. That's our first coordinate. Next, we use negative 1 times by negative 3, which is 3, minus 1 times by 2, which is 2, which is 1. That's our Y coordinate. The last one, we use 1 times by 1, which is 1, minus 5 times by negative 3, which is negative 15, which is 16. That's our Z coordinate. So now this is our vector W. Example 2, we want to verify the vector W is perpendicular to both vector A and B. Then we have to use the dot product. As long as the dot product equals 0, that means they are perpendicular. So we do vector W dot vector A. We multiply the X, multiply the Y, multiply the Z, add them all up, you are going to get a 0. Once again, we do W dot vector B as well. Then we are also getting a 0. Therefore, we know vector W is perpendicular to both vector A and vector B. Example 3. Given the magnitudes of vectors U and V and the angle between them is 60 degrees, we want to find the magnitude of the cross product U cross V. First, let's write down the cross product formula. Second, substitute the values that we know. Third, we know sine 60 is square root 3 over 2. Then we can find the magnitude of the cross product is 20 square root 3. Example 4. We want to investigate if there's a difference between U cross V and V cross U. Let's use two different methods to do it. So when we do U cross V, first, let's cover the X column. Then we will do -2 times by -4, which is 8, minus -3 times by 1, -3, which is 11. Second, the Y value, cover the Y column, 6 times by -4, -24, minus 5 times by -3, which is -15, you're going to get a -9. However, remember, middle term has a times by not a negative, which is going to be +9. Next, we want to find the Z value, cover the Z column, so we do 6 times by 1, which is 6, minus -2 times by 5, which is -10, which will be a 16. So we know our cross product will be 11, 9, and 16. Part B, we want to find the cross product of V cross U. That means vector V has to be on top and vector U has to be on the bottom. However, this time we're going to use a different way to do it. So let's write the vector twice. So 5, 1, -4, 5, 1, -4 for vector V, and 6, -2, and -3, and 6, -2, -3 for vector U. Next, let's cover the first column and the last column. Then we can do our calculations to find X, Y, Z components. So for the X component, we do 1 times by -3 minus -4 times by -2, which will be -11. Next one, we do -4 times by 6 minus 5 times by -3, which we're going to get -9. The last one, we're going to get 5 times by -2 minus 1 times by 6, which is -16. So I know our vectors are -11, -9, and -16. As you can see, U cross V and V cross U are not the same. They are opposite vectors. Therefore, we write A cross B equals to -B cross A. Example 5. Determine whether the following expressions are vectors, scalars, or meaningless. So for part A, we have vector A dot B times by vector C dot D. So we know for the first bracket, because that's a dot product, so the value inside the bracket will be a scalar. And second one, C dot D is also a dot product. That means the result is also scalar. And a number times by a number is going to have a number. Therefore, we know the result is a scalar. Part B. The value inside the first bracket is a scalar. And C cross D will result a vector. That means a scalar multiplication of a vector is going to be a vector. Therefore, a vector. Part C, the result of the first bracket will become a vector. And dot, the result of the second bracket is also a vector. And the dot product between two vectors is going to give you a scalar. Therefore, scalar. Part D, the result of the first bracket is a vector. Cross, the result of the second bracket is a scalar. But you cannot do cross product between a vector and a scalar. Therefore, meaningless. Part E, the result of the first bracket is a vector. Dot, a vector C, minus the result of this bracket, D dot E is a scalar. And we know a vector dot a vector C is going to be a scalar. Minus a scalar, the result will be a scalar. F. This equals to vector A plus a cross product between vector B and C is going to be a vector. And a vector plus a vector is going to have a resultant vector. It's also a vector. So, a vector. Example number 6. determine whether the two straight lines represent an absolute value sign or the magnitude sign. So we know if inside the two straight lines is a scalar, then it means an absolute value sign. If inside those two straight lines is a vector, then we know that represents a magnitude. Let's take a look at part A. So inside those two straight lines is a dot product between vector B and vector C. And we know the result is going to be a scalar. Therefore, it is an absolute value sign. Let's look at part B. We have vector A dot a cross product between vector B and vector C. So we know cross product is going to result in a vector. And vector A dot vector V is going to result in a scalar because that's a dot product. Therefore, it is an absolute value sign. Part C. Let's look at this bracket first. That's a cross product between two vectors. So it's going to create a vector. Then we're going to have a cross product between two vectors again. It's going to create another vector. Therefore, it is a magnitude. Part D. The first bracket is a cross product, which is going to create a vector. And the second bracket is a dot product, which is going to create a scalar. And then we have a scalar multiplication of a vector. It's going to create another vector. Therefore, it is a magnitude sign. Now, let's do a summary on cross product. So the cross product is also known as the vector product of the two vectors, which is going to create a vector that's perpendicular to both vector A and vector B. And cross product is using sign because they are all magnitude here. That means we have to have the magnitude sign around the cross product of A cross B. Then we have two different ways to find the cross product. One is to cover each column each time. The other one is write the vector twice and find out the values. And the cross product of AB is the opposite vectors of cross product BA. And cross product can only be defined in three-dimensional space.